Today we're going to look at how to calculate a confidence interval for the difference between two means. So I took this problem from the 10th edition Blumen book. It says, find a 95% confidence interval of the difference in the distances that the day students travel to school and the distance that the evening students travel to school. Two random samples of 40 students were taken and the data is shown below. Alright, so we need a 95% confidence interval. So the formula that you would be using is, I'll just label this confidence interval. We want to find the difference between the mean of the first group minus the mean of the second group. And that's our point estimate, plus or minus the z-test statistic with alpha over 2 times the square root of the variance of the first group plus the variance of the second group. Now, on your exam coming up, you'll be asked to find your point estimate, which is just the first piece, the x bar 1 minus x bar 2. That's your best guess of what the difference is. And then plus or minus some margin of error. So on your exam coming up, you'll be expected to be able to identify the difference. So this is your point estimate, and then this is the margin of error. Margin of error. That's what you're going to add on to your best guess, the point estimate. Alright, so we should have everything that we need to calculate this. It'll go pretty quickly. So it doesn't matter what you call group 1 or group 2, just as long as you're consistent. So I'm just going to say that's group 1 and that's group 2. So day students is group 1, so I have 4.7 minus 6.2 plus or minus. This z alpha over 2, that's the normal, standard normal distribution. Alpha over 2 is the area and one of the tells. So we need to find that value. Our alpha was 95% confidence interval means our alpha is 0.05. So we know our alpha is 0.05 because this is 95 and this is another 5 and it has to add up to 1. So if I pick one of the tells, confidence interval has two tells, right? You can have above it or below it. Each one of these tells is 0.025. This is another 0.025. So we're going to use the inverse normal to find this critical value, which will be negative 1.96, and this will be positive 1.96. Again, you use the inverse normal. Don't know why that's so messy. You would use the inverse normal to calculate those two values. So since you have a plus or minus here, you just pick one of them. So 1.96 times the square root of sigma 1 squared. So that's 1.5 squared over the 40 plus the 1.7 squared over the 40. Alright, so your point estimate is going to be negative 1.5. Let's try that again when it's not moving. Negative 1.5. The margin of error, when I put all that into my calculator, I get 0.702599. So you have two answers. You have 1.5 plus this value here, and then you have 1.5 minus this value here. So you have two answers. So you have negative 0.7974 all the way up to negative 2.20. That's your 95% confidence interval. I'm going to write that a little bit neater for you. Negative 0.7974 all the way up to negative 2.20. So we can be 95% confident that the true difference between those averages is in this interval. So just a little summary. We can be 95% confident that the true difference between the distance that the day students and the distance that the evening students travel. That the true difference between the distance that day students and evening students travel is between negative 0.7974 and negative 2.20. This problem does not give us units, but I'm assuming they're talking about miles. So again, that's how you would do the confidence interval by hand. If you wanted to use your TI calculator, you can. Just make sure you know what the point estimate is and the margin of error is. If you wanted to use your TI calculator, TI, then you would need to go to Statistics, and then over to Tests. Then under the Test menu, you would need to go to Two sample z-test. Okay. So using your TI calculator, Statistics, Test, 2 sample because you have 2 samples of data, and z because you're using the normal distribution test. And you would be able to get the confidence interval from your calculator. Feel free to email me if you have questions.